So we'll go ahead and get started. So today we're going to be talking about, I think it's very appropriate given the weather, right? It's starting to show that S word outside. We're going to be looking at, you know, we take a funny look at insulation and what insulation is doing as it's beginning to look a lot like insulation outside. A little play on for those of you in movie trivia, it goes back to our Wizard of Oz right there. So for those of you who may be joining us for the first time, again, we are the Minnesota Energy Code Support Program. We're here to provide some support and education, different resources to help building professionals across the state and building and reviewing, inspecting for energy efficiency in the buildings in our community. Primarily, we've been focused a lot on the commercial. We're going to begin in December to start looking at residential and commercial in that relationship. So if you have any questions, or if you're ever interested in hosting one of our trainings in your area, or for your local building department, whether that's an in-person or a webinar or something like that, please let us know. We're always here to help. You can get a lot of that information, and as well as some of the contact information there on our website, minnesotaenergycodesupport.org. You can either go to our technical documents, you can find our different upcoming webinars and trainings, and then also the Connect with Us section. Remember, we do put these past webinars on there, so those usually show up. I uploaded a bunch last week, so it should be live, but then you'll be able to watch those webinars if you have any specific questions afterwards. But we'll go ahead and get started. And I always start off with this concept that if we understand the why we do something, we can better figure out the how. And we talk about this every time. I think it's important to remember why we have building codes, and that's to provide for basic uniform expectations about how buildings are built in the state, and to create that uniformity so that things aren't built different in maybe rural areas that are different from maybe how we do it in more urban areas. So again, we create that uniform expectation about how buildings are built throughout the state so that a person could operate. It also creates consistency in the expectations among our building professions and our architects, right? If we know we have to build a certain way consistently across the state, it makes it easier for us than if we have to go jurisdiction by jurisdiction and make those changes to our plans and our processes. When we think about what the energy code is that component that helps us to address the concept of controlling heat loss, right? We're controlling how the amount of energy and energy utilized in maintaining a temperature that's designed for our buildings, right? We'll talk about that more as we start to get through this conversation. But we know that energy really in and of itself it's not the insulation, it's the mechanical systems and the lighting systems that are where we start to see energy savings and those controls that we place on them. But when we think about how the mechanical code, or not mechanical, my brain's a mechanical right now. When we talk about the energy code as a concept, it applies, as the code tells us, in new buildings, in additions, new equipment, new systems, alterations, changes of occupancy, right? We talk about its role even in some types of historic or existing buildings, right? We really start to see how the code is utilized in these different areas. Move this over here and put that, get some screen moving there for a second. So that's really the scope, right? When we really think about the energy code is one of those concepts that's really kind of everywhere we look around. We start to think about the modern construction today and moving forward for the foreseeable future. When we think about how that energy code is laid out, remember, we talk about every chapter within the commercial energy codes has its own specific, when we start thinking about chapter 5, 6, 7, 8, 9, and 10, we start thinking about them in different systems, right? We think about them as I call the 4 pillars, right? Chapter 5 is on the building thermal envelope, 6 is on mechanical, 7's on the service water heating, 8's on power, 9's on lighting, 10's on the other equipment. But within those different chapters, the ASHRAE standard is broken down so that we know what to expect when looking at them, right? So there's a level of pre-organization or consistency identified in it. And so we know that anything that ends in a where the second number in that code section is a 0.4, we're talking about one of the mandatory requirements of the code. When we think about prescriptive or alternative compliance paths, that's when we start talking about the 0.5, 0.6. Everything's got a 7 as far as what's supposed to be submitted with the packet at the beginning of the process, as well as some product information that may be required as part of a system. And so when we start thinking about those things, again, it drives us to this conversation of what are the compliance paths. And again, we understand those compliance paths. We talked about it before, and we will hit them more than once. And we're actually going to be talking about them in a residential context here in a couple of weeks. But when we think about them, they're the three options that we really see. Well, really the four options, but the three concepts when it comes to compliance paths are prescriptive, energy cost budget, which is in chapter number 11, and then our Appendix G performance rating process. So what we're looking for, and these are again, prescriptive is that checklist concept, right? Give me a list of what's expected within the building envelope, the mechanical systems, the lighting controls, the mechanical controls, and I'll do it, right? Just tell me what to do and I'll do it. Even within that, we understand, and we'll talk about in some today, when we think about installation, we're even given more flexibility, because just telling me to put an R30 in the wall is not enough. We're going to have somebody's going to say, I want to do a little bit different design. And that's where this conversation about insulation and the role of the thermal envelope is really all about the prescriptive potential that is there, the flexibility that is there. Again, we're looking at those other two performance-based compliance paths. We're really calculating how much energy at this building, as it's going to be designed, when it's installed properly, how much is it going to cost? How much energy is it going to use in the course of an annual year, given all the design components that we're going to have? And we can talk more about that. And again, if you have questions, please feel free to stop me. Let me, and we can have a little bit more deep conversations where we need to. So if you have any questions, put them in the chat, put them in the Q&A. Hope I can pay attention to the Q&A, but chat's usually better for me. And then we can kind of see where it goes from there. There we go. When we talk about the thermal envelope, right, we talk about that thermal envelope in the context of that baseline, that base of our building structure, right? We understand that there are certain mandatory provisions, and then there's also the prescriptive and building trade-off compliance paths. That's where we talk about follow the table or give me a com check, right? We did com check a couple weeks ago, and we'll do it again soon, I'm sure. But it's either, when we think about the envelope, there are certain mandatory expectations, but then there's, depending on what we're looking at, are we looking at fulfilling the requirements of the table or finding some other alternative where we can trade off some components to get compliance? Like I said, the com check. Remember, the thermal envelope is really that system that allows us to separate the exterior environment from the interior environment, right? When we start to think about here we're in Ohio where I'm at, today is the first day it's actually snowed. It started about 2 hours ago, and it's going to stop here in a little bit. It's not going to stick, but the reality is we want to keep that on the outside of the building and not on the inside as much as possible. And so with that, when we start to think about those different systems, we really start to think about how do we define it? And then that leads us to how do we review it? How do we install it? How do we verify it? Right? So these are the four basic concepts we ask in every type of plan review or code compliance check of a building component. Right? Where is it? How's it being designed or defined in the code? And then how am I going to review it before it goes out the door to be built out in the community? When we think about the building envelope, specifically, the state building code identifies the exterior wall envelope as those elements that provide protection from the detrimental effects of the exterior envelope, of the exterior environment, right? Again, that simple concept that the building's wall envelope protects us from the inclement weather, the rain, the snow, the heat, right? It's that building thermal envelope, right? The building envelope that we start to talk about here. And maybe one day when we come back on a code tag, we'll ask they throw in the word thermal just to help us even better define the building thermal envelope. Is that series of components that allow us to separate the conditioned space, right? Whether that's conditioned or semi-heated space, right? So it starts to think about, and a lot of times those are the same concept. right? They're the same components that provide us the environmental separation, but also because we're typically conditioning that separated space. We see a lot of times where the wall envelope matches with our thermal envelope. There's a lot of different elements that make up those thermal envelopes. They can include things like our exterior cladding, our insulation, or vapor barriers, or water barriers, or air barriers, or potential insulation, or gypsum, or some other interior wall surface materials. And so those concepts are pretty easy for us to understand. We see them whether it's in single family construction, or we see it in multifamily construction, or even in their traditional, like we're talking about today, traditional commercial construction. The concept of the thermal envelope is the same across all the different types of construction. I've used the example before. I'm sure I've likened it to the individual skin on our body, right? Every one of us has skin, and we understand that the role of the skin is to keep everything on the inside. And the same concept moves when we think about the thermal envelope, right? It's to keep the things that we've conditioned, the things we've typically paid or spent time creating that conditioned space. We want to protect it from escaping out into the general environment. Now, remember, the old adage that heat rises is not so much because it naturally floats up. It's because it's going from the greatest degree of temperature difference, right? And typically that's going to be the sky. That's going to be out of our buildings, right? Right now it's 70 degrees inside and it's 32, 33 degrees outside. Even if the heat that's inside this building is going to try to escape through the walls into the exterior environment to create that homeostasis, that equilibrium across the two systems. We get the same thing when we think about ventilation, right? Ventilation tries to go from highest pressure to equalize to lowest pressure. Heat does the same thing, and that thermal envelope is what's going to allow us to restrict or control how that happens. And I remember we've talked about this before. If there was one thing, the one word that I use to define the building off the codes in and of themselves, it's going to be the concept of control, right? It's all about control. It's controlling, the amount of sunlight that comes through the window, the amount of people that go through a door or through an opening, through an exit. It's all about controlling the load displacement. It's all about controlling the amount of air loss or heat loss through a building. 90% of us, I would tend to say, or more, generally when we think of our buildings, we're not expecting them to fail, right? If we were building a boat, we would expect that all of the water phases out of the boat, not just some of the water, right? Same concept when we talk about the construction of buildings. We're expecting to be built in a certain way with certain, minimum expectations and standards, and that's where the codes come in to help. Now, in that concept, like I said, the in section 5 of the commercial energy code, we really start to break out what are those mandatory. Now, remember, mandatory means it applies to all compliance paths, right? And the expectations are pretty general, but we see them there in the 3 different highlights, right? There's an expectation that we're going to have insulation, that there are going to be an expectation. There's going to be some windows and doors in that exterior, in that envelope, and that there's going to be air leakage controls that are incorporated into that design. And we'll talk a little bit about them. But again, those are the mandatory provisions that we think about, the things that we expect in every building. And if we were to parallel this with our residential, which we'll talk about in a couple weeks, we have those same expectations, right? It's a mandatory expectations, but we're going to have insulation somewhere. We're going to have some control over the doors and windows that we put into a building, because what's the point of having, we've also heard the adage, you weren't raised in the barn. Well, why? Because we understand that we have walls to keep in that heat, and we need to manage the doors and windows that are intended openings to make sure we don't have excessive heat loss through those systems as well. And then again, like we said, air doesn't move by itself. It's usually ushered out through temperature, through air leakage, right? If we think about I'm at a conference with some that's at an Amish restaurant, and they have some amazing pies. Right, today is Pie Day, and so they're preparing all the pies for pickup before Thanksgiving. If we took an apple pie and fresh out of the oven apple pie and put it on the table and put it in a vacuum and monitored the temperature, that pie will slowly cool because of convective nature of heat, right? Heat will move from the warm apple pie to the space around it in the absence of air. However, that amount of reduction in heat is directly related to how much air movement there is. If I put a fan against that apple pie, right? If I put a fan next to the apple pie and blow it across the room, yes, it will smell delicious. Let's all be honest. It'll smell amazing. But more importantly, that pie will cool faster, not because it was somehow the uh, it wasn't that the pie just became colder. It was that the air carried away more of that heat, right? So it's a concept that is near and dear to my heart as I sit next to all these amazing pies, right? That we 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 have these, so we understand conductive heat versus the impact that air can have on heat loss. So I digress and need to move on, right? But when we start talking about insulation, we know that there's certain expectations that the code provides for us. And in section 5.1, we start to talk about the recognition, the delineation, the definition of different types of space within our buildings, right? It reminds us that within our buildings, there are going to be conditioned, whether residential or non-residential, or semi-heated spaces. Now, it gives us the allowance and that we can have unconditioned spaces where approved by the building official, and the state gives us some guidance on that through its amendment, right? But more importantly, what we're looking for is we recognize that there are going to be spaces that are going to have different levels or different expectations when it comes to how we're conditioning those spaces. Again, semi-heated, non-heated, unheated, or semi-heated, unconditioned, and conditioned spaces. What the code tells us, if we look at it, is this red line represents the building wall envelope, where these yellow and blue lines represent thermal separation, thermal envelopes, right? And the expectation is that where we have this uh, I don't want to say congruent. When we have that, when they're layered on top of each other, right? When we have the difference between our unconditioned and conditioned spaces, or our unconditioned and semi-heated spaces, the thermal envelope that needs to be provided there is what the code is really providing for the minimum expectations, right? And so they're giving us these different variables within the individual tables to say, hey, if we're looking at a wall, it separates an element that separates conditioned and unconditioned space, or conditioned semi-heated and unconditioned spaces, then these are the expectations of those areas, right? Because we're going to be employing some level of energy to create that conditioning. And we want to make sure that we control as much of the loss as possible. So what's that going to look like? It's going to look completely different on different projects, right? This here is a set of multifamily buildings that we had. And so you can see it designated, depicted, defined, refined, however you want to use the term. I like the word depicted on this particular design. And so when they provided their drawings for this multifamily building, they provided a sheet specifically for all the elevations showing the building thermal envelope, or the building envelope. Same concept when we start talking about different commercial buildings, right? When we start thinking about the separations, they talked about this particular building before. This is our standard convenience store. And we have the exterior envelope, and then we had this space. If you remember, we were talking about creating a semi-heated space here for a receiving area for different supplies and materials. Well, then we realized that in the conversation, the designer said, well, what's really the point? I've got to do the same expectations for the thermal envelope, even if it's semi-heated, I might as well just call the entire thing conditioned and make my life easier. Well, that's a design issue, right? The design may facilitate that conversation. But when we start to think about, there are some designs that where we are going to have designated areas. This here is what was it? I think this is a car lot, or maybe it was some type of a car lot facility, right? So you've got the office space, which is obviously going to be heated. Then we've got these open bays, and you can see all the doors associated with it. I think, so we've got these open bays. Well, guess what? That's not going to always be conditioned. It might be semi-heated, right? It may have specific zoning heating, or it may have some type of warming systems. But again, it's going to have a different expectation when it comes to the heating capacities of those two spaces. And so we want to create a good separation, right? So that we understand that we're going to have some things that go in here. And we'll talk about those loading doors and the impacts on them when we get to that part of the conversation. And then we have a spray booth, and then we have a wash bay, right? Now this is an interior occupiable space, but again, it's not designed for, it's a semi-heated space versus this where they were at this paint booth where they were actually trying to condition it, right? They were trying to maintain it at a different expectation because of what activities were going inside it in comparison to this work area, right? So it's important to understand and to designate those different thermal barriers between the different types of space. That kind of makes sense? Okay. When we think about the components that make up our thermal envelope, obviously we've seen those delineated or identified for us in the tables in section 5, right? We start to think about the roofs and what does it mean to have a roof, the walls, the both above grade and below grade, and then we see our floors, and then our opaque or slab on grades, our opaque doors, our fenestrations. Again, remembering that not only do we have insulation, but we recognize that in that wall system, there's going to probably be doors and windows. And so the code provides us in one single sheet or one single table, those specific values for both fixed, operable, or influence doors for both our residential, non-residential, and semi-heated spaces, right? So we've seen this table before. We become familiarized with it as to what are the expectations associated with those systems. Now, remember, when we start talking about the variety of materials that are available, it's all about insulation, right? Just like Jan used to always say about Marcia, it's always about insulation. But in reality, while everything begins and ends with the thermal envelope and with insulation, it can't work by insulation alone. Because like we said, having that warm pie with that nice, amazing crust on top is not going to stop the heat from getting out of that, out of that apple pie. Now I'm starting to make myself hungry, right? We again understand that air has a role in the expedited loss of that heat, right? Air flows. Heat does not get up and walk, but air does. And so when we think about it in that context, you can get a lot more air movement through an assembly, or if you think about it again, you walk by some windows and doors, you can feel the draft. It's not that the air somehow jumps out. It's the air, or not that the heat somehow jumps out at you. It's the air movement that we recognize first. And there are methods for calculating air loss and air transfer and heat transfer as a result of that, right? There are testing protocols for determining the thermal convective properties, right? Or conductive properties of materials, right? That's where we get that concept of the R value, right? We're actually looking at, if we take the ASTM, I think it's 518, C518, we take that standard, we apply it to a material, we heat both sides and see how much of that, again, I'm thinking we put an apple pie into one of these component, one of these devices, we'd be able to see again how much heat is transferring from the bottom through the top, right? And that'll give us the R value of the pie. but it's not so much the R value, it's the U factor associated with all the different components in that system, right? We think about the box that it's in, the pan it's in, right? We think about all those components working together to maintain the temperature of that piece of delicious pie for our individual buildings. Sorry, this is the last training before Thanksgiving, so you're going to get some pie references apparently today, more than probably we usually talk about. But again, the code and the standards provide us this method for measuring these devices. But again, we have to always remember that air barriers are a critical component when it comes to it. They can't be that afterthought. Because again, the same way we talked about, they're going to, we call it scrub the R value, right? No matter how wonderful that thermal resistance may be, is if there's air moving through it, it's going to take that and push that air through with it. Again, also air movement has other consequences when we think about vapor and water transfer, pollutants, smog, exhaust, those types of things that can influence both indoor air quality and the comfortability of our buildings, right? We start talking about vapor transfer or vapor, the amount of humidity that comes into a building because of a failed air barrier or vapor barriers. Then again, they can have deleterious impacts or negative impacts on our building and our occupants. Again, and like I said, this is the perfect time of year to think about that symbiotic relationship, right? That of the insulated jacket and the air impermeable jacket, right? Today I wore a small air jacket, right? A small little windbreaker, and so I've got my thermal on, right? I've got my sweater vest on, so I've got my insulation, but I didn't need the air barrier the entire time I drove, right? I only need it when I go outside at 32 degrees because I don't need a whole lot of separation. Again, when we think about it in that context, we start really thinking that and recognizing that not all insulations are created equally. And to assist us in understanding the different types of insulation that might be out, again, for those that might be, this is probably a couple slides that are more specific to our design partners that are on with us today. But some of those different insulating materials may have different capacities. And so there are, just like there are for, us as building officials and architects, we have associations. So do the materials, manufacturers of these materials, maybe not the materials themselves, right? But the Insulation Institute, again, is part of that, is one of the .org, let me slow down. The insulationinstitute.org is one of those associations for the North, or for them to provide different product information and work through some of the different concepts as an industry for the bad insulation side of the traditional insulation. That's the North American Insulation Manufacturers Association. Again, NAMA is one of those things. Yes, I see a question. Is that a question? I can unmute you. Oh, let me resend it again. See, I'm glad you brought it up because you know how I am. Let me throw that in there. So that should be in there for everybody. So for those of you that got on late or got on after whatever time I put it on there, there's the handout if you want to look at it for now. But again, those associations exist to help individual manufacturers obviously come to some combined or some standards for how they present their product. The same again that we have when we talk about us as building officials, right? We have AMBO, we have ICC, we have different associations. They have associations as well. Those also include another great one is going to be the Air Barrier Association of America. This is more of that spray foam conversation where it starts to see materials utilized in different manners. So again, we can start to evaluate, especially for designers, evaluate different materials to provide both either insulating capacity as well as air resistance, right? Thermal and air barriers are possible. And a lot of times we think of them typically as either our spray foam or our continuous insulation, which is again going to be another association here that we see through the foam plastics applications for better building, right? Again, another association that exists. We've got a friend of ours who's come and done a couple classes, Jay Crandall, will be coming to talk to us from the American Chemistry Foundation to talk more about these types of products, so we can get and maybe we'll have them do a couple deeper looks into rigid insulation, because again, it's one of those products that properly installed, it can provide us that air barrier capacity, that air barrier. And again, we start talking about, I think we talked about this a couple of times when we talked about roof systems. The installation of insulation, we start talking about, well, the overlaps and how much overlap. And those are, again, conversations that are borne out through not just one industry, but it creates that commonality, right? The same thing we do. Again, we may have some great ideas in one part of the state, and so we use our association to educate and transfer that information around. Same concept, different part of our construction process. So we do one more. There we go. And so again, we start talking about some of those rigid foams, right? We talk about the association. That's where we start seeing the polyisos, the EPS, the XPS. And again, those are going to be systems that can be utilized in different applications, right? Each of those systems has different R values per in. Again, when we think about installation of those types of insulation, we start to think about, again, how are we're gonna overlap or what's the right word I'm looking for? Seal those different joints, right? We want to have the proper staggering of those joints, because those joints can actually have an impact on how we see heat transfer through a building, right? This is where we can start to see some of those examples where we remove, our traditional installed just batt insulation with R20.5 with no continuous insulation, and we see the thermal imaging of what happens. The heat transfers through that structural member, right? Because that structural member is not 20 R per inch, right? That's more of a 2 to 3, maybe 4 R, right? So the heat is not going to say, well, they intended for me not to go through it, so I'm just going to stop. No, the heat's going to penetrate where there's the potential for greater movement, right? Same thing happened. And so then we see here the installation of some rigid insulation in the exterior wall, and we see how it can impact. Again, does it stop it completely? No, but it slows it. We can see that little bit of a blue hue. It slows it to a significant degree. And that's where, again, we can start to talk about what degree, again, do we make it negligible in its heat loss? That's a conversation for architects and engineers to have. But again, it's really about understanding the impact of those types of materials on our buildings. And again, it's where we start to see the concept of these insulated concrete panels or insulated forms, right? We start to see pre-insulated materials, zip systems showing up, structurally insulated panels coming in, because again, we can standardize that process potentially and utilize these different materials for both their insulating as well as air barrier and structural components, right? Trying to make a better Lego in the real world, right? These types of materials, again, like we talked about, can provide a dual role. And in 5.8, we talk about air leakage, right? And the materials that are acceptable. And in that, if we have a minimum half inch or a minimum half inch of either XPS or polyiso, but not EPS, if you notice, again, if we have specific materials at these minimum thicknesses, then we can utilize them as part of an air impermeable system, right? If you remember, and we can talk about air barriers, but if we've talked about it once or twice, but if we utilize these types of materials in these locations, the science has shown that done it properly installed, these materials at these thicknesses will prevent air movement, right? When properly sealed and installed properly. So again, double duty in a type in a material. That leads me to the concept of spray foam, right? Closed cell, open cell. I always said the only way to tell the difference is if you lick it, but that only works with stamps, right? Spray foam comes in a variety of different types. There's actually 4 different types. We think when we think about spray foam, there's the sealant that we typically see applied in different air sealants, or maybe in a fireproofing kind of the can that we see walking around. Low density, which we call open cell. Medium density, we call closed cell. And roofing, which is even a thicker expectation of and how it actually cures. And so depending on the type of material we're talking about, again, what we're looking at is how quickly does the chemical inside the foam cure, right? If it's allowed to stay open longer, then those cells will break down, they'll open up, and then that chemical will actually escape, leaving an open cell that will be filled with air as it moves through a system, right? This is the reason why when we think about the types of insulation we use to make an air barrier, open cell needs 3.5 to 4.5. Oh wait, sorry. If we go back to, let me see if I've got it coming up. If I want to go back. So if we go back to if we look at our upcoming slide, right? Look at that again, that acceptable material used as an air barrier. If you look at the IECC, what it tells you is if you have 3.5 inches of open cell or 1 inch of closed cell, right? Then we can identify that it's determined to have that air impermeability that we need to have to identify and utilize it as an air barrier. Again, closed cell is going to be a different chemical makeup, and what it's going to do is it's going to cure quicker so that the interior space is filled with the chemical or the gas, right? Not with air moving in. So if it's already full, we know we can't fill it any further. That's the difference between closed cell and open cell. So again, it might be a question of asking as a designer, and again, understanding it as an inspector or a plant examiner, what material is requested, what material is approved or in the design, and then making sure it's installed properly in the field. Nothing would be more frustrating, at least in my opinion, than designer has gone through and said, I want closed cell. The plans examiner recognizes closed cell is going to be used as its air barrier because again, it was one of the approved materials that was allowed to be utilized to provide that air barrier. And then when we go out on the job site, they install open cell and nobody checks it, right? And so here what we expected, what we designed, what we spec'd doesn't come to fruition because of simple oversights. And that's why it's important that we check everything when it comes to making sure every piece of the project flows seamlessly. Spray foam is obviously one of those resources that can be utilized not just to as part of the installation, but also could be used to fill in some unique spaces, some unique voids, as well as in connection with other insulating materials, right? So you may have a design that calls for the installation of spray foam and then bat on top of it, right? Once it's cured or once it's allowed to fully express all the chemicals so that we don't impact its ability to perform as desired. Again, I would defer to manufacturers' installations or design details for that method of installation. And again, there's some that are provided as again, different reasons and rationales. This one here is a picture of a ballistic round resistant spray foam being applied to a building, right? So again, this is conceptually, if you shot bullets at it, that they would not penetrate because of the type of spray foam being applied. So again, different materials. We know some spray foam is used for fireproofing, some spray foam is used for soundproofing, some is used for thermal. So again, it's all about understanding what the expectation of that material was, and was it designed? Was it being installed based on what the manufacturer expected it to accomplish? Another insulation material that we think about once in a while is going to be our blown in. I got to remember to always say blown in. I used to say blow, and that caused some problems with some people in law enforcement. But we're not talking about blow. We're talking about blown in insulation. And we generally see that, again, generally see it as fiberglass and cellulose. And more importantly, we understand that the individual material, we understand the application. We want to know how it's being applied, how we're maintaining it so that we have adequate or consistent uh, filling across an entire space, right? Do we have baffles in order to make sure it doesn't move? Do we if we have a raised roof systems or raised ceilings, are we controlling its movement so we don't have we to make sure we have that consistency, right? If we're looking for 8 inches or 10 inches, that it's consistent across the entire building and not just folded down as a, or allowed to not saturate. But again, depending on what type of material, you're going to get different R values per inch of installation, right? Is it going to be uh, a fiberglass insulation versus a cellulose insulation versus our vermiculite? I always love good vermiculite, right? It's always fun to find in bags or find it in building still. But again, different materials are going to come with different both qualities and characteristics. Some may have more impact than others, right? So if you do find a project that prescribes vermiculite, know that it may contain asbestos. And so again, understanding how these different materials relate to one another. Not all blown in insulation is the same. Not all rigid insulation is the same. Not all spray foam is the same. And in the same way, we talk about that with bat insulation. And nowhere is it more obvious, right, than in bat insulation, because we start talking about, most of us think of bat insulation as the Pink Panther. I always go with Pink Panther fiberglass, but in reality, it's so much more than that, right? You have rock wool and sheep's wool and mushroom and wood fiber and hemp and straw bale and denim, and those are just the ones that we see a lot of. There are different materials as well. There's newspapers, and I've heard there are people that have all kinds of weird things in their walls. Um, and depending on what movie you watch, it could be even more fun within the walls. But when we think about that bad insulation, it's all about making sure this is where we start talking about that concept of enclosed on all 6 sides, right? We start talking about making sure we have continuity of contact so that we have consistent consistency and thermal uh, resistance, right? Well, I think we've got an example coming up here in a minute that'll show what happens when it's not consistent, right? But whether we're installing it in this kind of a fashion, we want to make sure that we're making sure it's consistently installed, that we don't have it may not always be the appropriate material for maybe some of our more unique or close installations, because you don't want to compress it, because it's that natural depth that creates that thermal resistance. And so you want to make sure that you think about them, right? And I love it. I love the comments, right? And I think that's where you do see projects. I had a project we tore down once, and I came in. It was literally, like you said, it was old newspapers, which actually ended up going to our historic society. So that was an opportunity for that. And so then you have the wood fiber bat, and again, like I said, there's a variety of different materials that we see utilized, from hemp to straw bale. Like I said, when I first heard of the denim, I thought that literally it was Levi jeans stuffed in a wall, until I realized it wasn't, right? But we have some of this. I've actually seen it at the Menards in our area. So again, there's different materials. One that I thought was interesting when I think about that insulation, and I know we have a few minutes left, was the mushroom, right? When you look at some of the natural materials that can be utilized, hemp was a natural material that fire might have some unintended consequences, right? Mushroom can have that same impact. When properly compressed, it has a tremendous. You see the fire test, flame resistance, right? Because of its natural, because of the way it's the natural capacities, right? And so again, you might see it identified or prescribed. And then again, one thing Hope always likes to make the point of is, if you had a mushroom installation in your wall and you had a leak, you'd know it potentially quicker than most as it starts to sprout, right? But again, different materials like rock wool, which is different from mineral wool, right? Rock wool is more of that basalt, whereas mineral uses just mineral waste, right? So there's different types of classifications of materials that we see identified in the code. Sheep's wool, again, another example of a natural material that it works for sheep, so it must be great, right? But it has some pretty significant R values when you think about it per inch. And again, it looks like it's lovely to lay in. But again, when we start to think about these concepts, remember, we have to define it, we have to review it, and then we provide. I don't know what just happened there. Do this, right? So we've had some conversations about these in the past. So again, you'll find the different it's one of those things that we talk about a lot in energy code compliance, because it's not the issue that uses energy. I think we talked about that before, right? It's not, we don't have plugs plugged into the wall insulation, but what it is that wrap that isolates and maintains that conditioned space so that those energy consuming components operate more effectively, right? And so there's a variety of different resources out there that we've put together and videos to help out with that. Remember, slight deviations in little things. Let me see how many slides we got. Oh, we got enough. Slight deviations in the design of a building can have significant impacts when we look at how it complies with the code, right? In this example here, we're looking at climate zone number, I think this is 7. And so in a non-residential setting, we have minimum expectations of R value and maximum expectations for U factors. And so as we see in our example that we've talked about, I'm sure more than once, we've got a simple wall that's got a wood frame wall. And so that wood frame wall, they prescriptively, we provide 2 different options in the U factor and the R value. And then we have 1 U factor. And so we see that we start to add in, some cavity and continuous insulation under that minimum expectation. But what we can do is we can start to see the ability to modify some of that cavity and reduce and trade off, right, some of the different materials. So if we want less continuous, more cavity, then we can get to that same expectation when it comes to what the U factor is. That's really what we're kind of getting here in this conversation, right? And that's where it's important for us to also identify when we're reviewing a project, what components are supposed to be are designated in what location, because sometimes we have thermal separation, and then we have things that are going to be more of that sound separation, right? So we start to look at a project and we'll pull out the insulation schedule. Now the reason this one was changed is because they gave us this nice insulation, but they provided no R values for it, which is again kind of what's the point of it. But when we start to zoom in on these, we can see that some are provided in roof systems as blown-in insulation, and then we see some bad insulation, right? We start to see these symbols that represent something. And again, it's important that we understand what those symbols are calling for. And then also, how does that get installed, right? We're going to fill all the fiberglass. We're going to spray the polyurethane in certain areas, right? So we're going to make sure that we think about how they're going to be installed so that we know where it's expected to be. And so when we see this type of drawing, this type of separation, right, at first glance, we see them identify this as my thermal envelope. Well, then we start to ask the question, well, why is this insulated, right? Is this for sound attenuation, or is this going to be part of a separation between multiple units, right? So those become questions that we need to figure out and start to draw out. We see here the identification of sound attenuation bats, right? So what they were intending in that second floor roof deck detail is they start to explain to us that we're looking for a 1.5 inch sound blanket, right? Material there on number 4, right? And so again, we start to identify them, we start to understand how they're being used, because it's the question of why is it, and then we can figure out the how it gets installed. And it gets into the whole what. This one I always love to point out because it just drives me crazy, right? It's the mislabeling of features because we see here this is called bad insulation. We see the bad insulation symbol, but then we see it called out as spray foam, closed cell spray foam, right? So again, one of those things that when we think about how do they get built and how do we have consistency, these are the types of things that we identify and say, hey, if this was the only note, then we might say this is just a note approved as noted, right? But this was not the only note, so it was one of those. Hey, please clarify whether that's going to be closed cell spray foam or if the symbol needs to be changed to reflect the appropriate symbol on page, whatever that was. Sorry, right? So again, when we start talking about that installation of insulation, we have to think about what does the code expect, right? The code gives us some examples, both in when we think about the mandatory prescriptive mandatory requirements, the prescriptive in that, and the trade-off, but also gives us the product installation requirements in 5.8. That's when we start to get into how are they properly installed, right? Are they going to be pushed in, bunched up, and leave these voids that we see exist? Or are we going to have areas where we're going to have incongruities between, we called for a certain depth of insulation, but now we installed spray foam here and back here to get to that same level. Is that going to be consistent with what the plan was designed to provide us? And again, we start to identify, 3 inches of rigid insulation that gets us to an R15, 1.5, it gets us to an R7.5, right? To gives us a total of 22.5. Whereas in this wall system, we see a 3/4 inch of rigid at 3.8 and a 5.5 at insulate R20, right? So again, we start to see that some walls are designed to operate differently. And so that's where it's important for us to make sure we check all the wall details. And then when we're installing them in the field, we can see, our contractors can see what's the expectation for successful completion of a project. So again, it's all about verifying what was expected, what was going to be done in the building. I don't know why it keeps doing that. Thinking about, again, what do our details look like? We're supposed to have, again, different type of slopes associated with going to a roof drain. Are we looking at staggering? What are we looking at? Are we looking at an insulated covering? Or are we looking for a membrane to cover? It depends on, there's a variety of different installation expectations. And that's where, again, comes back to what are the details, and when we're inspecting it, making sure that as a plans examiner, I've got the details in place so that my staff, when they go out and do their inspection, can have clarity as to what they're looking at. And sometimes, again, it's about identifying and making sure every feature is properly and adequately identified, right? We see our R19 bat, our R7.5 continuous, we've got our air barrier, we've got our thermal break associated with the materials that we see out there. We've got our GINS glass, we've got our polyiso as well, which again is outside of our actual rigid insulation that we're utilizing as part of the thermal, because again, we're going to be maybe having different materials employed in different ways. And what we want to make sure is that what we see in the field matches with what we have on the paper. So again, we don't see these areas where we've got inconsistencies. I don't have it in here. I thought I had the thermal image. I took in the thermal image of it showing how that gap impacts the temperature of the space, right? And the actual movement of air and heat through that wall system. But again, we want to make sure that we have consistency in what we see here with what we're seeing here. And if we see that's an R15, not an R19, and this is not labeled at all. So what, it becomes a question as an installer, as an inspector, I see an R19 identified, you've got R15. I don't see anything identified up here. So I need to have some clarity as to how this is supposed to meet that requirement of the code. So with that, I know we got a few minutes left for any questions anybody might have. I'm going to keep going through some slides, but if anybody has questions, raise your hand or again, throw it in the chat. I haven't looked to see if the Q&A doesn't look like everybody's in the Q&A. Now, remember, when you get an opportunity, fill out your survey. Again, if you've not already given your DLI or your AIA license numbers, please put them in the survey, as well as give us some ideas on topics for the upcoming conversations in the year. We're going to be looking, I think, in the next week or two to start to really think about what is the next series of trainings. Let us, again, know if this time works for you, because that's an important question for us. And, as we think about, is this the right day? Is this the right time? This is what we had. We've sent out our first survey a couple months ago when we had very few people who knew who we were. So again, let us know what you're thinking. Remember, next week, happy Thanksgiving. No webinar. I will probably log in, but I will not tell you, right? So don't show up next week. Enjoy yourselves. Like I said, we're going to get in, start talking about a residential compliance pass and residential design in December. Again, if you're interested, we do have, again, that upcoming in-person training in Rochester on Tuesday the 3rd. It's a full day set of trainings, but we've broken it up into 2 different groups. So there's a 7:30 to 11:30. It's a 4-hour training on mechanical systems. Then we'll take a lunch break and come back and do power and lighting systems in the energy code from 12:30 to 3:30. But if you have any questions or if you're interested, let us know. Go reach out on the website. For those that might be MAPMO, Minnesota Association of Public and Mechanical Officials, MAPMO, we're going to be on MAPMO training on cast iron and plumbing in the energy code on Monday the 2nd in December in Maple Grove. So those who, I know there's a few of you that have both building and plumbing. And so that might be something to look forward to if you're interested. If you have any questions, you can always submit it to the helpline, or you can send me an email, send Hope an email if you ever have a question. But I appreciate everybody getting on. If I don't see you before then, happy Thanksgiving, happy Christmas, happy New Year, all that stuff rolled up into one, but hopefully I'll see you before then. And again, if I'll be in town, the metro area specifically, the first week of December. So if anybody has any questions or wants to get together for coffee, send me an email, let me know. And again, I appreciate you guys. You have a great week. Be careful, and we will see you next time.